All right, so we have 5690. All right, so what we did, all right, we covered the test. We've done all the tests. Now this week we're going to be covering 3.1, 3.2, and 3.3. All right, so we'll cover 3.1 right now. But just understand that next week we'll not have any classes. There's no classes next week because of spring break. All right, so let's take a look at 3.1. All right. All right, now we've kind of covered this a little bit, all right, with input and output section, where it says it wants to know the number of tours, tour groups. What are the number of people if we have 2 tour groups? Well, each tour has 60 people. So it's a matter of just realizing that, well, if I have 2, then it's going to be 60 times 2, or 60 plus 60, which is 120. So it's a matter of multiplying. So 4 times 60 is 240 people. 7 times 6 is 42. So it's going to be 420. So we go ahead and compute that, and then we graph the coordinate points. If we had 2 groups, then we have 120 people. We have 4 groups, we have 240 people. We have 7 groups, we have 420 groups, or 20 people. All right, and so we're graphing each coordinate point, and then we're checking it. All right, so that's pretty straightforward. So it's multiply, write it down, and then graph it accordingly. Let's try another one. So the store is selling laptops for $700 each. So if we're selling 3 laptops, then it's 3 times 7 is 21, but then you have 2 zeros, right? And of course, I'm doing this all in my head. You can write this down or put it in a calculator if you desire. But then it's 4 times 7 is 28, so I just do 28 with 2 zeros. All right. So 6 times 7 is 42, and then 2 zeros. It's really easy to do it when you have 2 zeros. All right. Now graph that. So 3 laptops gives me 2,100. 4 laptops gives me 2,800. And then 6 laptops gives me 4,200. And you notice how they give us the increments over here, exactly what we need. They're doing that on purpose. I mean, because they know what the outputs are going to be, because they're incrementing in values of, the 700. I mean, they do 350 and then 700, and then 350 more than 700. And you know what I mean? So every other one is going to give us our values that we need. So I mean, it's a nice, convenient setup for that they gave us. All right, now this comes down to learning about how to find slope. And I have a really good strategy for finding slope. All right, so what I want to do is I'm going to explain first. Slope is finding the value of incline between two given points. Now, to distinguish between the points, this is being point 1 and this being point 2. They subnotated the values of these x and y's because otherwise there's no distinction between them. It's really hard to find what's different between these other than the subnotation. So they go ahead and subnotate this as basically telling anybody who's looking at it that this is point 1 because it's subnotated 1, and then this is subnotated 2 because this is point 2. So that way you can go ahead and tell the difference between it. Now this formula says that slope is equal to the value of the difference between this coordinate point right here minus this coordinate point here. And then it's also this right here is the other one. So you're doing the difference in the y's over the difference in the x's. Now, you can have an alternative way of looking at it. You can say that you can do y sub 1 minus y sub 2. Doesn't have to be y2 and then y1 first, or it has to be in that order. It doesn't have to be in that order. But whatever order you do choose, you have to make sure that the x's are doing the same exact thing. Because it's only natural for you, you to go ahead and take and count in order by 1 and 2, right? I mean, I don't know why the formula says take y sub 2 minus y sub 1. It doesn't have to. As long as you don't crisscross them, you're okay by doing y sub 1 minus y sub 2. Now, this is all fine and dandy. It's only this, all this does for the student is confuse them. All that does is confuse students. All this confuses students. They get all discombobulated. They mess up their signs. They do all kinds of stuff. So I don't teach that way. Yes, I introduce it to you because it's my obligation that I have to because it's part of the lesson. However, I'm going to go ahead and write these two numbers down, or these 2 points, I should say. And I'm going to give you a strategy set that you don't need to worry about formulas. Now, here's how I go about doing this. Now, you got to listen to this and be careful with how I'm saying this. You can go back to my recording afterwards, by the way. This first strategy you want to do is switch the signs of the 2 points, well, not 2 points, but the 1 point, but you want to switch the signs of x and y on the second point. All right, that's the first strategy. Get that in your head. Switch the signs of the second point. Do not switch the signs to the first point. Now, add your y's together because it's always y and then x. Y and then x. So add your y's together. So what is -3 added to 7? And then add your x's together. -9 added to -7 is -16. And then reduce your fraction. Done. That's all you have to do. Not any of this writing down stuff. All right? I can't make it easier than that. That is as easy as it can be. All right? So I plug that in. put in a negative sign. The negative sign could have been up top or the bottom. It doesn't matter, but we're in the middle. Let's try that again. Now, remember what I said. Switch the signs at a second point. Add our y's together. Add our x's together. And simplify our fraction. And there we have it. Now, do you guys understand how to simplify fractions? If you don't, please raise your hand and let me know, or say, hey, Mr. D, can you review that so I can understand how to reduce fractions? Because otherwise, if you don't say anything right now, I'm assuming you know what the heck you're doing. Okay, so nobody's saying anything. So I'm assuming that you know how to go from here to here and here to here with no problem. Because now I'm going to go ahead and plug it in. So I'm going to put a negative, and then I'm going to put in a fraction, 3/2. All right, let me do something here. All right, I'm going to ask you a simple poll question. Do you like this strategy? I mean, do you find this strategy to be simple? I mean, an easy approach? I have one response so far. I mean, that's one of the reasons why I'm asking this, because, guys, I want to make sure that you're paying attention to it. I want to make sure you're engaged. Because I know if I taught this using this formula right here, all right, you would be ultimately what I said is confused. All right. So far, I have 3 responses. Okay. So I know that some people, what I'm afraid of, and this is what every synchronous teacher is afraid of, all right, is that there's students who come to synchronous and then they turn on or come to class and then leave. I mean, or fall asleep or not engage. And I have 3 non-responses so far. I have one student who said, no, I don't even like this way. And it keeps you anonymous, which is nice. Okay, you don't like the strategy. So that's okay. And I don't mind that people don't like the strategy. That means you're using this right here, because there's no avoidance of being able to figure it out. You have to figure it out some way. So you're going to go back to what you did in high school. And I hope that you get it right. That's it. I mean, that's all I care about, is you getting the right answer. All right. So again, I have people who are lacking response, meaning they're not even in the class. They're here, but they're not here. Okay. So this is done. All right. Now I'm going to go ahead and show you a couple more times if need be. But this is again the problem. Let me go ahead and write down for that person who said no. I mean, you don't have to make yourself known. That's why I did the poll. It's anonymous. All right. That I'm going to try to make you a believer. And it's up to you whether or not you choose to do it this way. If not, then so be it. Here's my strategy again. Switch the sign of the second point. Add my y's together. Add my x's together. And simplify my ratio. So negative divided by negative is positive. And 2 goes into both of these. All right. 7 and 4 times. And there's my answer. All right? That's as simple as it is. So I'm going to put the ratio in as 7/4. All right? Like I said, I cannot make that any easier. All right? For that person who said no, because I'm gonna go the extra mile for you. All right? I'm going to do it the old-fashioned way. I'm going to do it this annoying way. All right? I'm going to do it this way, and I hope, and you're going to see how much longer it takes me to do it. All right? They don't have another question. I would like to do a similar question if that's the case. Then, let me. Man, they don't have. I can't do a similar. Maybe that. I want to try to find a similar question. All right, and they won't let me. Okay, I'm gonna go ahead and make up a set of numbers. All right. I mean, because I just want to show you. Well, you can look at this example, but if you look at this example, I mean, that's one way you could do it. But I mean, here is the setup. As a matter of fact, that's how I'm going to show you. Look at the setup and how much more work there is on the setup. And that's exactly what I had shown you. So yeah, I would have to go through and explain all these pieces to you. And this is how you learned it in high school. All right. And wow, that's a lot of work. That to me looks like a very intimidating way of learning it. So I find it very hard to believe that the way I'm showing it is not the simplest way of doing it. Okay, so yeah, I'll leave it at that. And if I run across another problem, then I'll do it. Okay, now these questions right here. All right, if we look at this, it says the bucket is filled with water. All right, is being filled with water. The graph below shows the water height versus the time the water has been running in seconds. Use the graph to answer the question. It says how much does the height of the water increase for each second the water is running? So if I look at it, 1 second goes by, the height increases by 5 millimeters. So there's my answer. And what is the slope? The slope is going to be exactly the same. It's going to be 5/1. Because that's what slope is. So it says, how much does the water amount increase each hour? Well, it goes from, at 1, it goes from 200 to 300 after 1 hour. So it's increasing by 100 liters. What is the slope? It's increasing by 100 liters per hour. So it's got to be the same exact answer. Okay, here I'm going to do this by the old way of doing it. All right, this is the old way of doing it. First, I have to go ahead and recall what the slope formula is so I can recall where to put the thing. So I have to remember this in my memory. That's one thing I have to do. I have to call this out as x sub 1, y sub 1, x sub 2, y sub 2. Have to remember to do that. Then I have to go ahead and do this. Look at the formula. Okay, so this is 9. I'm going to put 9 here. I'm going to put the minus sign. Then I'm going to put y2 here, y1 there. Of course, I'm being very careful not to mess it up. And then I got 7. I'm going to put 7 here. All right, and then I'm going to go ahead. Oh, I got to do a negative sign. I got to remember that. Then I have a double negative here. I got this negative. So I have to remember to consider the fact I got a double negative. Now, I do 9 minus 3 is 6. And I got to do the double negative, which is, I got to rewrite that as now positive 5. So then it's 7 plus 5, and that's going to give me 12. Then I got to reduce it down to 1 over 2. So isn't that a lot more work? I mean, I just, like I said to you before, cannot imagine that a student would find that to be more desirable than simply switching the signs of the second value, add my y's together, add my x's together, and then simplify. See, the idea is here, I wanted to purposely show you this, that my signs are different from the originating or the value of this formula. And the reason why is because I'm doing this. Without you even knowing it, I'm doing this. And that's why the signs will be different, but the ending result will be the same. All right? So you don't need to worry about this. I didn't make you worry about it. I just simply showed you how to make it easy. Okay? So the answer is 1/2. If I didn't make you a believer there, then then there's no making you a believer. You have to use the formula all the time. So I'm not going to show you again that way. That's ridiculous way of doing it. Okay, so what is the temperature at 0 kilometers? So 0 kilometers, the height is at 0 when it's on the ground, right? Or at, excuse me, on the ground, meaning it's right here. All right, so this is 1 kilometer, this is 2 kilometers. So now 0 kilometers, the temperature is going to be 45. So that's what we're going to be at 0. So it's going to be 45 degrees Celsius. Choose a statement that best describes the height and the temperature are related. As the higher you go on a mountain, right, the higher you go on any elevation, if you're doing a plane or whatever, the temperature is falling, all right? As the height increases, the temperature decreases. That's what's happening. And it's decreasing by what? Okay, so after 1 kilometer, this thing dropped from 45 to 30. So that's 15 degrees Celsius. All right, that is dropping. Okay, and it says that at the rate of temperature decreases 15 degrees Celsius per kilometer. Now, at the candy factory, what is the amount of candy contained at 0 minutes? So 0 minutes is right here at 40. All right, choose a statement that best describes the time and the amount of candy are related. Okay, so obviously the candy factory is making candy, right? It's putting candy into a container. So after 1 minute, it goes from 40, all right, pounds to 160 pounds. So that's an increase of 120 pounds. So it's as the container, as time is increasing, the amount of candy containers increasing by 120 pounds per minute. Now the cost of a pack of 16 pens is $3.68. Find the unit price. Now the way to find unit price is by taking, all right, it's $3.68 for 16 pens. All right. Now we want to know the cost per pen because this is for 16 pens. We want those pens to be 1. So what we're going to do is multiply this by, or actually divide each of these by, I should say, 16. Because by doing that, right, by doing that, oh, I'm sorry, I'm not even showing you my page, sorry. Okay, by doing that, by putting 368 over 16, you're going to divide both these components by 16, so that way you'll get your pens to be 1. So taking your calculator, do 6. Well, you don't need to do 16 divided by 16. You know that's going to equal 1. So do 368 divided by 16. And you're going to get 23 cents. So that's going to be 23 cents per 1 pen. All right. And that's what we're looking for. So it's really simple. Just take and divide the money by the number of whatever item you're given. And that's unit rate. You're making unit rate because of you want to get your unit, how much it costs per unit. So here it's $24.30 for a pack of 9 towels. So that by default, then it means we're taking 24.3 and dividing it by 9. So that's going to be $2.70. Now it says unit price for 6.08 kilograms of bag. So the thing is that Susie paid $10.47 for that. So it's how much per kilogram is just taking 10.47 and dividing it by 6.08. So it's going to be round up to near a cent, $1.72. Now the other one right here was 13.88 divided by the 7.48. And that's going to be $1.86. Now, which one's the better purchase is going to be the 608, right? Because that's how much, that's a lesser price than the $1.86. Be mindful that that kind of question is what you'll find on the test. Okay. So again, it's 389 divided by 72, because always price divided by unit, and then you get 5 cents for each fork. And then you look into the next one, you're looking at 662 divided by 96, and you get basically 7 cents. All right, now which one's better price is brand A, whatever's a smaller price, right? Costs 5 cents per fork versus 7 cents per fork. Now this one, it says write the number of widgets made per hour for each machine. Well, all right, so per hour, so we're going to take 4 divided into 16, because that'll be getting the hours down to 1 hour. So that means that for machine A, it's 4 widgets per hour. All right, 8 divided into 56 goes 7 times. And then 9 divided into 54 goes 6 times. So per hour, the machine that was the fastest would be 7 widgets per hour, and that's machine B. All right. If you have any questions, let me know. I mean, I think I'm making this pretty straightforward. All right, but that is the answer. That is the last question that was given. So that covers the lesson for 3.1. So we covered the slope formula. If you need me to go over that more with you, just let me know. I can pull up a resource for it, but it's pretty straightforward. It's change the signs at the second point, add your y's, add your x's, and then simplify your fraction. That's what you should have gotten from that. And then this is just nothing but application of units per, or the unit price or unit value. All right. Are there any questions? All right. In that case, then I'm going to stop the recording.